Hi, my name is Maria del Carmen Garcia. This is the project number 1 for Technical English 1 course. Today we're going to talk measuring water flow rate and volume using Arduino and a flow sensor. We will start with an introduction about the project. The most common sensor used to measure the flow of a liquid is a flow sensor, by using a flow sensor with a microcontroller like Arduino. We can calculate the flow rate and check the volume of liquid that has passed through a pipe and control it as required. In many industries, we have to constantly measure and qualify the liquids that are handled during the process or during an automation process. And the most common sensor used is a flow sensor. Also, we can find this type of sensors in agriculture or food processing, water management, and other industries. By the way, we can find this everywhere where we need to monitor and control some liquids. Water flow gauge system use a flow rate gauge containing Hall effect sensor that outputs a pulse rate proportional to flow rate. This system can identify the rate and volume of water by means of a water flow rate sensor. Also, the Arduino flow meter works on the principles of the Hall effect. According to the Hall effect, a voltage difference is induced in a conductor transversal to the electric current and the magnetic field perpendicular to it. Here, the Hall effect is used in the flow meter using a small fan propeller-shaped rotor, which is placed in the path of the liquid flowing. The liquid pushes against the fins of the rotor, causing it to rotate. Now we're going to talk about the project and the objective. The project consists to build a water flow sensor using Arduino. We will interface the water flow sensor with an Arduino and LCD and program it to display the volume of water, which has passed through the bulb. For this particular project, we are going to use the YFS201 water flow sensor, which is used as Hall effect to sense for the flow rate of the liquid. Components. First, here we have the water flow sensor. We have here the LCD display, refers to a small device with a liquid crystal display that has 2 rows of 16 characters each, used to display information. The pipes. To connect the pipe and the water flow sensor, we use 2 connectors with a female thread and shown. Batteries. It's optional if you want to use a battery. Also, you can use your USB cable. A potentiometer is an adjustable resistor which consists of a wiper that slides across the resistivity strip to deliver an increase or decrease the resistance. These are connecting wires, or known as jumpers. Also, we have the Arduino Uno. There is a microcontroller board based on the 18 Mega. It has 14 digital input and output pins and is based on an easy way or easy to use hardware or software. Those were the components and the circuit diagram. The water flow sensor circuit diagram is shown below to the interface a water flow sensor and LCD with an Arduino. As we just see in the image, the connections required for this flow rate sensor with respect to the Arduino are very minimal. There are only 3 wires coming from the flow rate sensor. The first one is the red wire, and we're gonna connect it to the 5 voltage pin, and the black wire, we're going to connect it to the ground, and the signal or pulse pin, we will connect it to the yellow wire. And from the LCD to the Arduino microcontroller, we are going to connect the ground to the VCC pin. The pulse line of the flow rate sensor is connected to the Arduino's digital pin 2. The Arduino's digital pin 2 serves as the external pin or the interrupt pin 0. And here we have a video about the connections for this project.
Let's take a look at how we would measure the flow of water. Say you have a hydroponics project or other lab experiment, and you don't need very precise readings. This is not going to get you as accurate reading of dosing, say, like a peristaltic pump would do. But this one actually does quite well. If you can see inside, I know it's really hard, there's a little water wheel in there, and there's a magnet and a Hall effect sensor in here. And every time that wheel spins, the sensor triggers a high or low. And that makes it really easy to work with, but it also makes it a little inaccurate. So basically, every time the sensor in here is triggered, it's the equivalent of about 2¼ mils. So let's hook it up. This is easily done by simply connecting. If I look underneath this little bit of rubber here, there's a red, and red goes to 5 volts. In fact, I don't even need a breadboard for this one. And again, if I look in here, there's black. That goes to ground. And the last one is our signal, just like a standard Hall sensor. And that we're going to put into digital pin 2. So we're basically going to read a pulse, an on or an off, or a change in pulse. So now that we have this hooked up, let's take a look at that code. I'll load up my Arduino, and I happen to have the product page for this particular flow sensor right here. And if I scroll down, I can click right there, and you see there's a GitHub, and I can actually just grab the code that they posted there. See, it's a fair amount of code, and like I said, it's pretty complicated measuring whether it's on or off in a very, very fast rate. And we'll copy the code. No libraries are needed whatsoever. And here is how you hook it up. This also includes the liquid crystal library because I can simply add 6 more wires and have a little LCD display showing how many liters have passed. But I'm not going to use that. I'm just going to use a serial monitor. So let's go ahead and make sure my Arduino is plugged in. Board, port still going. There it is. Upload this code. Oh, and it wants me to save it, so I'll call this flow test. Now it's compiling and uploading. See the flashing. And I really don't always like mixing electronics, especially when I've got my laptop and everything here with water. So in this case, I'm just going to blow through here because I think I can just blow on that wheel and it should spin and we should see an output. So let's open up the serial monitor and you can see I'm getting, let's stop it from scrolling. You can see I'm getting 0 pulses and 0 liters have passed through. So let me just blow through this really quickly. And we'll pause it real quick. And you can see I now have 0.26 liters and I've sensed 116 pulses. So the software is able to very quickly and very accurately measure when a pulse comes in, and then it can convert those pulses over an amount of time and do some simple math to figure out how many liters have passed through. So that's a basic overview on how to measure water flow. One other thing to note, there is a direction on here, so you are using multiple sensors or if you're using a level, that can be really important. Really easy to hook up. 3 wires, some free to download code from Adafruit, and you're good to go.
Here we have the simulations for the project. The sensors code we use for this Arduino water flow. What we did is that we attached the water flow sensor to a pipe, and then the output voltage of the pipe is the output of the water flow sensor, and it is 0. That means that it's no pulse. And if the output valve of the pipe is open, the water runs via the sensors make it returns, which it turns revolve. In this situation, we can see pulses which are produced from the sensors. These pulses basically will work as the interrupt signal of the Arduino Uno. The current time and loop time assure that for every second of the bulb and the flow frequency is used for calculation of flow rate and volume. Once the calculation is completed, the flow frequency variable is set to 0 and the complete producer is originate from the beginning. Here a video of the simulation for the project.
So this is the test setup for the flow rate sensor over here. I've attached a PVC pipe and a funnel on top to pour down water easily. The other end is inside this plastic bottle. I've connected it to an Arduino and the code is running on the PC. The liquid flow rate will be updated on the Arduino serial monitor. I'm also using a measuring cylinder to measure the water, which I'm gonna pass through the flow rate sensor so that we can check its accuracy. So the beaker has about 300 ml of water right now. You just check the accuracy of the flow rate sensor now. So it shows 330 ml. The company says that the sensor offers about plus or minus 3% accuracy, so it works fine, even though the accuracy is just a bit off. But we can work with it though.
And now we have conclusion and applications. For the related applications about this project, we have the following. River flow monitoring, mass or volumetric flow rate pond monitoring, balancing system flows, treated wastewater, sewage water system, uh, fuel and lubricant flow, irrigation, and water use. As a conclusion, we have that this is a very wonderful project that can be used in the industry or our homes or at water flow measurement applications in a water trap, tunnel, river, or anything. Water flow sensor for flow rate and volume measurement using Arduino code. And this is all. Thank you so much.